Welcome to Ask and Learn.
Here we have the equation for the rate of change of the fish population. And for the first part of the problem, we want to know what would the rate of change be if the population was stable? Well, a stable population would not be growing or shrinking, so the rate of change would be 0. For part B, we want to know if we use the numbers given, what the stable population level would be. So using the numbers given and using 0 for the rate of change, let's find P of t, the population level. So we can substitute 0 in our equation for dp dt. We were told R naught is 5%, so we're going to use 0.05. We have 1 minus P of t divided by 10,000. And then we have the unknown P of t again, minus 0.04, that's the beta value, times P of t. So our goal is to solve this equation for P of t. So let's start by adding 0.04 P of t to both sides. And we have 0.04 P of t equals 0.05 times 1 minus P of t over 10,000 times P of t. Now, I don't know about you, but I would rather not have all these decimal numbers in here. So I think at this point it would be nice to stop and multiply both sides of the equation by 100. So now we have 4 P of t equals 5 times P of t times 1 minus P of t over 10,000. All right. Now notice that we have a factor of P of t on both sides. Let's go ahead and divide by it. And now we have 4 equals 5 times 1 minus P of t over 10,000. All right, so let's go ahead and distribute the 5. Get rid of those parentheses. And now we have 4 equals 5 minus 5 P of t over 10,000. Well, that fraction could be reduced. 5 over 10,000 is just 1 over 2,000. 1 over 2,000, yeah, that's right. So we'll do that on the next step. Let's subtract 5 from both sides. We get negative 1 equals negative P of t over 2,000. Now we can multiply both sides of the equation by negative 2,000, and we get P of t equals 2,000. So what is that telling us? That's telling us for those particular values, that beta value, that rate, that everything, the stable population would be 2,000 fish. And now for part C, we're going to look at what would happen if we changed beta to 0.05 instead of 0.04. Now, I think we can safely go back through without redoing all the steps and just look at what would happen if our 0.04 became a 0.05. This would be a 0.05. This would be a 4. Or sorry, this would be a 5. This would be a 5. And at that point, we would subtract 5 from both sides, and this would be a 0. Then we would multiply both sides by negative 2,000, and we would get the population is 0. And that would tell us that basically there's no way to have a stable population with that beta value.